Guten Morgen, meine Damen und Herren, and willkommen in iChem. Yes, welcome to iChem in any language, although I can only speak German and English, so if you want me to say that in Russian, sorry, I can't. We are in our unit on heat and energy, heat and temperature, let me put it that way. And we went through last time and talked about latent heats and phase changes. And one thing that we talked about was this beautiful diagram here, right? Yikes. I still think, I should sign these things. I could sell them for modern art, don't you? Good. Oops. Zoink, 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 zoink. Wunderbar. Hey, look at that. Abracadabra. We were talking about this, right? And we said that in this area I have ice. In this area, what's going on? I have fusion going on, meaning I have melting. In this area, what do I have? I have liquid water. In this area, what's going on? That is vaporization. And in this area, what do I have? I have gas. And we said in each of these areas, you have to calculate the heat added in a different way. So let us jump into that question. How do you calculate the heat of that? Consider 200 grams of ice, and we're going to start at minus 25. How much heat is required to transfer this ice to steam, which means gaseous water, right, at 125. So really, we want to do this exactly. We want to start at 25. We want to go to 125, and we want to figure out how much total heat is added. And what we said last time is that in the ice range, we say Q ice equals M ice, C sub P ice, delta T ice. Now, what's the delta T ice? Well, delta T ice starts at 25 and goes to 0. So delta T ice is equal to 0 minus a negative 25 in this case. So our delta T ice in our equation here, our question here, is 25 degrees Celsius. During the fusion phase, how do I get heat? Well, Q fusion is equal to M fusion. Well, that's going to be the same mass all the way through, times delta H, my latent heat of fusion, right? There's no delta T in this because there's no change in temperature. In my liquid area, Q for my liquid is equal to M liquid, C sub P liquid, delta T liquid. And what's my delta T liquid equal to here? Well, I go from where? Let's see. I start at 0 and I go up to 100. So it's going to be 100 minus 0, which is equal to 100 is my delta T liquid. What do I do here? Well, that is vaporization. So Q vaporization equals M vaporization delta H vaporization, the latent heat of vaporization. And then finally, I have my gas area. And how do I get Q gas? Well, Q gas is equal to M gas, C sub P gas, delta T gas. And what's my delta T gas? Well, it starts at 100, goes to 125. So my delta T gas is equal to 125 minus 100, right? 25 degrees Celsius. Now remember, these delta T's are going to change every question. However, one thing is always certain, right? For water, it always will begin changing from the solid to the liquid at 0. So that means my ice never goes, my final temperature of the ice range is always 0. And it doesn't start to boil, it doesn't start to vaporize till 100. So my T final of my liquid is always 100, as long as we're talking about water. Now, if I talk about methane or methyl alcohol or something like that, then it's a totally different curve there, and we have to look up the temperatures, the boiling point and freezing point temperatures. Got it? Here we go. Are you ready? Yes, I am. So let's do these one step at a time. What is my Q ice? Q ice, we said, is M ice. How much M do I have? 200 grams. C sub P ice. Where's my C sub P ice? C sub P ice is right here. So 2.09 joules per gram Kelvin. And then what's my delta T? My delta T, we said, was what? My delta T was going from 0 from minus 25 to 0, so that's a 25 Celsius delta T. Good. Now notice that's K and that's C. Is that a problem? No, because that is a delta T. Remember, the delta T is the same in Kelvin and in Celsius. So let's run the numbers. Here we go. 200 times 2.095 times 25. And what do I get? I get 10475 what? Joules. How many sig figs? I can get 2 sig figs out of well, no, let's see. I can get, let's see, 0. Yeah, I can get, actually, that's a double, that's a 0.0. Sorry, I forgot about that. I get 3 sig figs out of this. 1, 2, 3, so that means those guys are not significant. Okay, fusion. What's my Q fusion? Well, my Q fusion, we said is 200 grams times delta T fusion. Not delta T, delta H fusion. And it looks to me like that is 0.334 kilojoules per gram. Easy. 200 times 0.334 equals 66.8. How many sig figs? 3, 3, 3. I'm going to carry another fig, and we'll round that later if we have to. Kilojoules. Good. Q liquid. And that's going to be M liquid, C sub P liquid, delta T liquid. Hey, my M, my mass, oops, stays the same the whole time, right? 200 grams, C sub P liquid. Yoink. 4.18, not times, 4.18 joules per gram Kelvin. What was my delta T? Let's see, what was my delta T for my liquid phase? I went from 0, up to 100. 100 minus 0, we said, is 100. Okay, so my delta T is 100 Celsius. Once again, this is a delta T, so Celsius, change in Celsius equals change in Kelvin. Let's run the numbers. 200 times 4.18 times 100 equals 83600. How many sig figs? 333. So that's not a sig fig. Joules. Good. Q vaporization. How do I get Q vaporization? Well, I'm going to take my mass, 200 grams, times my delta H, vaporization, 2.26 kilojoules per gram. And let's do some multiplication. 2.26 times 200 equals 452.0 kilojoules. Right, and the first 3 are significant. And then finally, whoo, mama, Q of my gas, which would be my mass gas, 200, times the C sub P gas. What's C sub P gas? C sub P gas for water is 1.84 joules. 1.84 joules per gram Kelvin. And what was my delta T gas? Delta T gas, holy moly, this is getting uglier and uglier. Yeah, like some of the women I've dated recently. Good. We ended up at 125. That's my T final. Where did I start my gas? My T initial was 100. 125 minus 100 is 25. Okay, good. So then we drop in a 25, and that's 0.0 degrees Celsius. I think there's 3 sig figs. No, I don't think there are. Let's look at that again. Who can tell? Who can tell on that one? They don't give us enough information. We're going to let these guys drive our sig figs, okay? Because I'm not sure that we should have more sig figs in our 100. Our 100 has to be 100 point. We know that. Okay, good. So here's our sig figs. 200 times 1.84 times 25, and they get 9200, and that's not significant, joules. Okay, wonderful. So now my total heat is what? Well, then my total heat, my total Q is equal Q ice plus Q fusion plus Q liquid plus Q vaporization plus Q gas. Whoo, mama. So we just start adding these all together. But one danger here. What is that? Look at that guy is a joule, and that guy is a kilojoules. Sometimes you're going to get your delta H's in kilojoules, and that means you're going to have to convert those kilojoules to joules or vice versa. So let's do that, and we'll be careful as we add this. Okay, QIs 10475. 10475 joules, and that was the last two are not significant. Okay, plus Q fusion was 6680 kilojoules, 6680 kilojoules, but there are what? 1,000 joules per 1 kilojoule. Ach du Liebe. Good. Plus, 83600 joules plus what? 4520 kilojoules times what? 1,000 joules per 1 kilojoule plus 9200 joules. Okay, so now let us go ahead and multiply these out for a second here. 66.8 times 1,000, and I get, this is really 66800, and what, that, those little guys are not significant. So that's 6680 joules. And this other one is 452 times 1,000, jawohl, and that is 452,000, and these guys are not significant, and so this is joules. Now I do that to look at my significant figures. I can only be significant to the, what, ones, tens, hundreds, thousands. So when I have my final answer, I can only be significant to the thousands. Now, add these all up. Are you ready? 10475, woohoo, plus 66800, plus 83600, plus 452123, plus 9200, and I get 622 622, and then I round this 000 joules. Cool. And that's how much heat is required to do our job there. Holy coly. All right, what time do we have here? Mamma mia. Okay, so you guys do the next one and bring me back when you're ready. Okay, the first thing that I would do is I would make a nice little picture here, okay? I'm going to do this, and yonk, 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 yonk. And what do I start at? I want to start at -1. So I'm going to put a -125, and I'm going to go zoink up to what? Well, that's going to be up to 0, right? Because that's where I make my ice becomes liquid. Then I'm going to go from 0 to what? I'm going to go from 0 to 100, because that's going to be my liquid range. And then I'm going to vaporize, and then I'm going to go from 0 to what final temp? 115. Okay, good. So that helps me see what I have to do. All right, so Q ice, well, that's going to be equal to, what's my mass? 125 grams times C sub P of ice, 2.09 joules per gram Kelvin, times delta T. Well, my delta T is 0 minus a -125. Oops, 0 minus a -125. So what's my delta T from here to here? It is 125. So let's write down 125. Good. So I have 125 times 2.09 times 125, and I get 3, 32656 joules. Cool. Now, what is my Q of fusion? Well, what's my mass? 125 grams. What's my delta H fusion? Let's look up here. 0.334 kilojoules per gram. Hey, and let's just go ahead and convert this to joules right now, okay? So then 1,000 joules per 1 kilojoule. Got it? So then what do I have? 125 times 0.334 times 1,000, and I get 41750. 3 sig figs out of that, so those guys are not significant. Cool. Q liquado. Yes. Here we go. 125 grams times what's my C sub P of my liquid? How about how about this? 4.18. 4.18 joules per gram Kelvin. What's my delta H? I go from 100 to 0, right? We're talking about that range right there. So 100 degrees Celsius. Okay, 125 times 4.18 times 100, and I get 52250 joules. And how many sig figs? 3. 1, 2, 3. Doink. 1, 2, 3. And then what do I get? Q, liquid, what's after fusion, liquid, vaporization. So 125 grams times delta H, vaporization. What's delta H vaporization? There's delta H vaporization, 2.26. 2.26, did I get that right? Yeah, 2.26 kilojoules per gram, but let's go ahead and convert that to joules right now. Cool, there we go. 125 times 2.26 times 1,000. Mamma mia. 2828500 joules. 3 sig figs. 1, 2, 3. So that's not a sig fig there. Good. And finally, Q gas. 125 grams times C sub P gas. What's my C sub P gas? C sub P gas is 1.84. For, of course, water. If that were something else, then it would not be 1.84 joules per gram Kelvin. And what's my delta T? My delta T is 115 to 100. So 115 minus 100, and I get 15. Okay, 15. 15 Celsius. Good. 125 plus 1, not plus, oink, 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 oink. 125 times 1.84 times 15, and I get 3450 joules. And they only have 2 sig figs here. Good. So then, when I add all this stuff together, what do I get? Let's try it. Are you ready? I go with 32656 plus 41750 plus 52250 plus the big mama 28250 plus 3450 equals, holy cow, 41206 joules. And I am limited to what? Right here, I am limited when I add these things up to the thousands. So anything that's not 1,000 has to be rounded. These guys all have to be rounded, so it becomes 413,000 joules is our answer. Ooh, let's make sure we're right. Let's add that up again. Are you ready? 32656 plus 41750 plus 52250 plus 28250 plus 3450. Woohoo! I got the right answer. I hope you guys got this too, and I think this is enough for this time. Next time, we got a couple others to do, but I think I want to give us more time on that. So we'll have heating curve calculation part 2 next time. Enjoy life, folks.